All right, let's restart our problem for the day. I had written down the hyperboloid, and I thought, oh, this will be awesome. This will be a nice opportunity to call back chapter 12 and say, here's a hyperboloid of 2 sheets, and we're using the level surfaces to analyze it. That part is incorrect. The idea of finding the level surfaces of F tangent to the constraint, that still applies. We do have some different level surfaces. Now that I've dropped one square off with the y, we could solve this for y, and we're just going to get paraboloids. So here's our constraints. Now we're just looking at elliptic paraboloids. For different values of f, we'll just have different elliptic paraboloids. And we're looking for the same thing that we were before. We're looking for which of these elliptic paraboloids is going to be tangent to that surface, to the sphere. That means we want to set the gradients in the same direction. I want to look for where the gradient of f is pointed in the same direction as the gradient of g. That is, the gradient of f is equal to lambda times the gradient of g. So I want to set up the gradient of f is some scalar multiple of the gradient of g. That means the gradients are pointed in the same direction. That means the surfaces are tangent. So this vector equation gives us 3 equations in x, y, and z, and lambda. And our 4th equation is just from the constraint. I also need x squared plus y squared plus z squared is equal to 1. So now we're looking at a nonlinear system, and we didn't study solving specific techniques for solving nonlinear systems like we did with linear systems. We spend lots of time studying linear systems and learning different prescribed techniques. But in nonlinear systems, it's just like, do something. So this is where we have to take all of what we know about solving systems and kind of like throw it together, because we have a nonlinear system. I've got one of the things I'm looking for multiplied by another. So nonlinear. Also, I got these x squareds down here, nonlinear. So here's what we're going to do. We're going to break this into cases. So this happens a lot. We're trying to solve this system of equations rather than try to follow some prescribed path where we do elimination or we do addition. We're just going to start breaking things into cases. That's why I picked this problem, because it has some things that are easy to read. This first equation, where x is equal to lambda times x, tells us a few things. If x is equal to some constant times x, that means x either has to be 0 or lambda has to be 1. So this tells us a couple of things. First, let's take a look at this. This means that either x equals 0 or lambda is equal to 1. If x is 0, then lambda can be whatever it wants, because lambda times 0 is 0 and x is 0 on the other side. But if x is not 0, then lambda has to be 1. So when I say x is 0, this includes lambda is anything. But if lambda is equal to 1, x can be anything, because then x is just equal to 1x. So either x is 0 and lambda is any, or lambda is 1 and x is any. So that first equation has given us 2 cases to work with. X is 0 or lambda is 1. Let's pick one of those and run with it. If x is equal to 0, let's take the first case where x is equal to 0. If x is equal to 0, that means this first equation is, well, doesn't tell us anything. And we get the -8 equals lambda. I'm not going to color code anything anymore. And 18z equals lambda z. And then this third equation will just be y squared plus z squared equals 1. So x equals 0 takes out that first equation and reduces our fourth equation to a circle. Now, we're going to grab some more cases. Take a look at the equation we have now. -8 equals lambda y, 18z equals lambda z, and y squared plus z squared equals 1. That 18z equals lambda z tells us similar stuff to the first equation with the x. So 18z equals lambda z tells us either z is equal to 0, in which case lambda is anything, or lambda is equal to 18, and then z can be anything. So inside case 1, I've got 2 more cases. Z is 0, or lambda is equal to 18. I don't like labeling things too much, but this would be like case 1a, and this would be case 1b, because these are both results of x being 0. If z is equal to 0, I'm hesitant to label things because people start thinking that they have to label things, and you don't. If z is equal to 0, that means we get -8 equals lambda y. Z is equal to 0, so it takes out this second equation. And this third equation becomes y squared equals 1. If y squared is equal to 1, this tells us that y is +1 or -1. Now we can start backing out. Oh, actually, now we have x, y's, and z's. So this gives us 2 values for x, where x is 0, and then we drill down to z equals 0, and then we found out if x is 0 and z is 0, then y has to be plus or minus 1. So right now we've got 0, 1, 0, and 0, -1, 0. Let's go to case 1b, where lambda is equal to 18, and z can be whatever it wants. If lambda is equal to 18, then this first equation becomes -8 equals 18y. The second equation just tells us that 18z is equal to 18z. And so we're like, oh, wow, thanks for the big revelation there. And then the last equation, or the third equation, says y squared plus z squared is equal to 1. I'm replacing lambda. So that one didn't get any smaller. This second equation is kind of useless. 18z is equal to 18z. It's like, oh, no kidding. But that first equation, -8 equals 18y, tells us something. It tells us that y is equal to -8 over 18. Once we have y is equal to -8 over 18, I can put that into the third equation. And now I'm going to get two different values for z. We don't have a second case for y. Right now, in this case, in everything that we've done so far is based on this, where x is equal to 0. When x is equal to 0, that brought us to two cases. Either z is 0 or lambda is 18. So now I have to look at the case where z is equal to 0. That told us that y is plus or minus 1. I have values of x and z of both 0, and I get two values for y, 1 and negative 1. So now I'm in case B where lambda is equal to 18. So when lambda is 18, this first equation gave us that y is equal to negative 8 over 18. And now I can put that one value of y into our y squared plus z squared equals 1 and find two values of z. So now I have, so in this case, here are two values of z. I need to know what these are. So this looks like 260, square root of 260 over 18, the square will drop out. So now, this is all still based on x equals 0. And we got one value of y, negative 8 over 18, but we got these two different values of z. So now I've got these 2 points. I've got x is 0, y is negative 8 over 18. And this lead us to a square root of 260 over 18. 0, negative 8 over 18, and negative square root of 260 over 18. Simplifying over here, I needed to solve this equation for z squared. The 18 squared is 324. Wait. 18 squared is 324. And then 324 minus the 64 from the 8 squared is the 260. So now I've got 4 points to check, all based on x equals 0. Any questions? This was all just an analysis based on our first case where x is 0 and lambda can be whatever it wants. We still haven't done case 2 where lambda is equal to 0. We've got 4 on our list that we have to check. We're going to check these values just by plugging them, or check these points, excuse me, by plugging them into our function to see which one is biggest and which one is smallest. So if x is not 0, I need to realign this. If x is 0, then lambda can be anything. If lambda is 1, then x can be is not 0. So let's look at that second case where x is not 0 and lambda is equal to 1 and see what that tells us. This is going to be case 2. So if lambda is equal to 1 and x is not 0, then the first equation is just going to be x equals x. And yeah, thanks for the revelation there. The second equation tells us that -8 is equal to 1 times y. And the third equation says that x squared plus y squared plus z squared is equal to 1. So since y is -8, we're going to plug the -8 into the second equation. And that's going to tell us that x squared plus -8 squared plus z squared is equal to 1. And that's going to tell us that x squared plus 64 plus z squared is equal to 1. I just saw what time it is. Sorry for the delay. I got distracted by my angry coffee and also by copying the problem down. So I'm going to post the first video, and I'll post that first page of notes as well, where I started off on the wrong problem. But we've got 4 points to check in by plugging into the function, see which one is biggest and which one is smallest. And I want you to all to look at this equation and say, what is this telling us? See if you can get any points out of that, and you can let me know what those points are tomorrow. Any questions? Comments? Deep thoughts? All right, that's going to do it for today. Thanks for putting up with me starting off on the wrong problem and letting me just start over again. Kind of embarrassing, but I'm going to post that video anyway because no one's watching. No one cares about my YouTube channel. It's pretty awesome. I bet if I started playing some copyrighted music, then YouTube would be all over it. Like, stop. You know what I mean? I don't want to try it because someone might need the stuff, and I don't want them to have like silent videos. Although if I could play old-timey ragtime piano, then I would just have silent videos, which would be kind of awesome. And just have like sepia tone the whole video, and I'm like writing stuff. And then I would speed up what I'm talking, like this part, like if it shows me, then I'll just go really fast and like exaggerated. Meanwhile, like this ragtime piano is playing in the background. And then if I write final exam on Friday, then then it's like duh. Then the music gets all threatening. You know what I'm talking about? I don't know how many old silent movies you've seen, but that's what's playing in my head right now. All right, that's going to do it for today. Sorry for going a little overtime. Sorry for the false start on the wrong problem. I'll post both of those videos. Everybody have a good day. I'll see y'all on tomorrow, and thanks for playing.
Thanks, Professor.